All right, number 6, we have that the gravitational force, and they've given us the letter F, between the object and the Earth is inversely proportional to the square of the distance from the object and the center of the Earth. So again, force, they're using force, but it's really mass or weight. Okay, so they've given me the weight of the astronaut. That's what we're going to put in place of the force. So it says astronaut weighs 204 pounds on the surface of the Earth. What will this astronaut weigh if he is 3,750 miles above the Earth? Assume that the radius of the Earth is 4,000 miles. We're going to round to 1 decimal place. So, here's what we got. Mass, or his weight, whatever you want to say, is equal to inversely proportional, so K, divided by the square of the distance from the object and the center of the Earth. So I'm going to say D squared. D squared. What they're saying is that you have the Earth here, okay? The center of the Earth, they're telling you that the radius is 4,000. Okay, so right now, the first time we're doing this astronaut is 4,000 miles from the center of the Earth, because he's on the Earth. They say he's standing on the Earth. So here's my little stick figure. He's on the Earth. Right now, he weighs 204 pounds on the Earth. Okay, so mass right here, this is 204 equals K divided by the distance he is from the center. So distance is how far he is from the center. The radius is 4,000, so he is 4,000 feet from the center, and we have to square that. So 4,000 squared. Okay. So to find K, we're going to multiply 204 by 4,000 squared, okay, which this is really 16 million when we square that. We get really big numbers here. So let's just compute this with the calculator. And it's going to give it to us in scientific notation, but we're going to be doing 204 times 4,000 squared. So really big number here. We get, let me see, 1, 2, 3 zeros, 4, 5, 6. So we're in billions. 3,246,000,000. Okay. So 3,246,000,000.
Yeah.
Okay, I am dyslexic. 264, sorry. Million. Okay, this is equal to K. This is my K value. All right. Let me move this calculator out of the way now. Then they give us the second part. So this is kind of hard to piece together for the first time, but now the second part of this equation. We want to know what will this astronaut weigh. So we want to know what is his mass if he is 3,750 miles above the Earth. So now this is what we're looking at. His weight is the distance he is from the center. So now we have this astronaut here. Here is the Earth, which is 4,000. And then he is an additional 3,750 miles above the Earth. So all together, I have to do 3,000 plus 4,000 to find out how far he is from the center. I need to find out this distance. So it's the 3,750 plus 4,000. So this whole distance is 7,750. Okay, so that will be his distance. This is D now. And his mass, we don't know, but we do know K. So we're going to input this information. You still have to square this big number. So right now we have his mass, which is what we're looking for, is equal to the K value, which is 3,264,000,000. That's on the top, divided by the 7,750 miles squared. This is going to give us how much he weighs when he is this far above the Earth's surface. Okay? And I'm just going to number crunch this. Calculator is going to do this for me because these numbers are much, much too big to do by hand. Okay? So I'm going to type in 3. No, you can just type it in 3, and you can. The parentheses won't hurt, but you don't have to. 3264 000 000 divided by, and then I'm going to do 7,750 squared. Now, since it's only two numbers I'm dividing, one on top, one on the bottom, I don't need parentheses, but it doesn't hurt to put them, and it's always safe to put them. The whole top in parentheses, the whole bottom. So this time I get 54.3, round to one decimal place, and it will stay 54.3.